The idea that integers and strings are immutable seems to be contradicted in the very same segment of code that's meant to demonstrate that they're immutable. So let's take a look again. We noted before that my integer has the same value when line 8 runs as when line 11 runs. And that's a demonstration of how my integer is immutable, in some ways at least. We might also say that that's a demonstration of how Python passes by value instead of by reference when dealing with integers. But in a second, we'll actually see this has to do with mutability. The challenge here is look inside add1. Add1 takes as input an integer, adds 1 to it, and then prints the new value of that integer. When add1 starts, it receives the value 5, but when it prints an integer on line 4, after adding 1 to it, its value has changed to 6. So doesn't that mean that integer is not immutable? Its value just changed. The variable and integer used to have the value of 5, but now has the value of 6. We're changing its value right there. So how can integer be an immutable data type? We just saw its value change in one of the simplest programs we can imagine. We can actually make this even simpler. Just take a look at this extremely simple program. This probably is one of the simplest programs we can imagine. We create my integer and give it the value 1, and then we change the value of my integer to 2. If my integer was immutable, wouldn't that still say 1? Clearly its value is changing. Now brace yourself, this is about to get weird. What I'm about to explain is definitely on the computing side rather than the programming side. This is the inner workings of how Python actually executes this code. For all practical purposes, you can generally think of integer being a mutable data type. You can generally think of this as changing the value of my integer. But let's talk about the way Python actually does this. We've talked in the past about values and references. We have a variable called my integer, and when we assign it the value 1, we're telling it to point to a place in memory that stores the number 1. When we use my integer, we're actually looking up its value. Now we might think when we say my integer equals 2, what we're doing is changing the value at that location to 2. That would be a reasonable assumption. That's not actually what's happening though. What Python does is kind of weird. Instead, it grabs a new area of memory, puts the number 2 there, and tells my integer to point at that new location instead of the old location. What that means is that the old value is still there in memory. The value didn't change. We didn't change the number 1. Instead, we just created a new place in memory and told my integer to point to that instead. So technically, we're not changing the value of my integer. We're not changing the number 1. Instead, we're creating a new value and telling the variable my integer to point to the new value instead. This might make more sense in terms of our analogy from before. Let's say we have file A, has the name A, and has the value 5. I've drawn 5 in black to indicate it's written in permanent marker. We can't change the number 5 written on this piece of paper. But imagine we want to change the value of file A to 7. What do? We can't erase the number 5. So we take out a new sheet of paper, we write the number 7 on it, and we declare the old A is no longer A. Only the new A is A. We're just saying, okay, this file on the right is our new file A. Forget that there ever was an old file A. We never change what's written on the original piece of paper. We just change the name of it, or we remove the name of it. But what's interesting is that the piece of paper never goes away. We still have the value 5 stored in memory. What that also means is that if later we discovered we needed the value 5 again for a different variable, let's say we needed the value 5 for the variable b, we could just say, okay, now this piece of paper is named b. Or if we needed multiple variables to all have the same value, we could say that this piece of paper is now b, c, and d. There's a difference between the name of the piece of paper, or the name of the data, the variable name, and the value of it. So this is exactly what Python is doing in this little block of code. We create a variable called my integer, and we assign it to the value 1. That happens on line 1. Then on line 2, we want to reassign my integer to the number 2, and so we create a new space in memory, give it the value 2, and tell my integer to point at that new place instead of that old place. But the spot in memory holding the number 1 doesn't go away. And so if a new variable comes along that needs the value 1, maybe something called my other int, then it could now point to that spot in memory to have the value 1. Changing the value of my integer changes the spot in memory that it points to, but it doesn't actually change the value stored in the original spot of memory. So let's tie this back to our Addison example real quick. We drop 2 files, file A and file B, on Addison's desk. On them are written the numbers 5 and 2. They're written in permanent marker, so Addison can't change them on these sheets of paper. But Addison wants to change the value of A to 7. So what does he do? Well, he pulls out a new sheet of paper, calls it A, writes down the number 7, and then declares that the old A is no longer A. Only the new A is A. But what's interesting here is that the names are only local to the individual. He can call whatever he wants A, but he can't force us to call his new file A. That's what's happening in our previous chunk of code. When the function add1 runs, it creates its own local variable called myInteger and points it at the number 5 stored in memory. MyInteger, the variable from the main program, was pointing at the same number. So both myInteger and anInteger are pointing at a space in memory that holds the value 5. When line 3 runs and says anInteger equals anInteger plus 1, Python evaluates that expression, determines that the answer is 6, and so it creates a new place in memory and gives it the value 6. AnInteger is what's being set equal to that new value, so now anInteger points to 6. It no longer points to 5. Note, though, that myInteger still points at 5. So this function can't change what value the variable used in the main program is pointing to. It can only change the value its own copy of that variable is pointing to. As I said when we started this is a pretty complex topic, and it really covers the inner workings of how Python evaluates these things. If it's confusing, you're welcome to just keep following your previous understanding that Python basically passes integers and strings as values when calling functions. Functionally, that understanding is correct, although it doesn't describe the way Python really works under the hood.